Well, we had a few requests to see how we actually connect to SpeedBall during development. Some people wanted to know about all the serial cables we used. Today we've only got about 3 serial cables running into the payload. I'm doing development today on the satellite controller software. You can see the COM controller is the blue Arduino file down there, directly in the middle of your screen. And you'll see the cables. There's 3 of them leading down to the file. There's one to the program port on the actual Arduino. There's one running to the green PCB below it, which is the COM controller. And you can see that's connected to the satellite debug port. And then a third is connected to the satellite host port, which is the actual data line running between the satellite modem and the COM controller, for example. But all of the boards in here have serial ports that can be used for debugging. This is the flight computer you see down there at the bottom in the center. It has all of the bus lines going to all of the different modules on there. Each of those pins and those connectors are the same all across all the connectors, providing power and data to each module so that they theoretically could be interchangeably plugged into this flight computer without messing anything up. Here you'll see in the blue bag is the actual GPS module and its associated antenna up here on the frame. You'll see the cut down board hanging below our payload support frame. It's got internal data lines that you can see there, the red, purple, and black. There on the yellow perf board is the Arduino ballast controller, and over here is the sensor controller, another Arduino file on a PCB, and it has lines leading out to the cloud sensor, for example, and all the other sensors in the payload, which primarily are down here under our strobe light in the sensor housing. The cables actually come out of the payload and run down here in a harness to a USB hub, which we have very fastidiously labeled. Without the labels, USB serial ports quickly get to be a complete mess. If someone ever switches the USB port, it will change the COM port number on your computer. You'll see here is a bus pirate from SparkFun Electronics that is allowing us to issue I2C commands to the flight computer. This is our ground support board, which is another AVR that is used to interact with the payload while it's all sealed up and on the ground. It provides a remote terminal interface to all of the modules inside. It provides basically a debug serial output from all the modules. Each module issues an I2C command to this board to display text externally, and using these 2 modules before launch we're able to configure all of the boards and systems inside without having the box open or being directly connected to those. The ground support actually provides power as well from these 2 cables here, from either the battery pack or a large power supply. Provides between 9 and 18 volts through this, believe it or not, RS-232 serial cable, which is not being wired the way they're normally, up through to the external connector, which carries the power, and also the I2C data bus to and from the ground support, which is right next to the flight ground power switch, which will cut off the power from this cable and energize the power from the internal battery packs. And you see this headphone jack hole here is the actual device that's used to trigger the flight software into thinking it's in climb out mode. There's a headphone plug that will be yanked out of that right at launch. So that's the state of SpeedBall-1 today. Keep an eye out for it in the sky one of these days.